The topic we're going to talk about for this video, on this video, is related rates and optimization problems. Okay. So again, you will need to pause the video and then do it on your own, and then you can watch after. Okay. Let's look at it. Number 3, the volume of the cube is increasing, rate of 300 cubic centimeter per minute at the instant when the edge is 20 centimeter. Find the rate the edge is increasing. Let me quickly draw the cube. So you have that cube. All the sides are congruent because of cube. Volume of cube is x cube. Okay. Now what they gave you is dv dt is 300. Okay. Then cubic centimeter per minute. That's what they gave you. And then when, what is a dx dt when x is 20? Okay, that's the question. So you just write down what's given. So when you take a derivative from here, you take a derivative both sides in terms of t, dv dt. This is a related rate problem. And then 3x squared dx dt. Okay, you take a derivative in terms of t. Now you substitute given. So dv dt, left hand side 300, and 3, x is 20. 20 squared times dx dt. Okay, so that is 300 over 400, right? 400 times 3 is 1200. That is a dx dt. So 1 out of 4, right? dx dt is 1 over 4 centimeter per minute. Okay, that's your final answer. That's how fast the edge is changing. Okay, let's move on. Let's do number 4 first. Now, number 4, sand falling at the rate of 30 cubic feet per minute forms a conical pile whose rate is always equal to twice the height. I find the rate. The height is changing. At the instant, height is 10 feet. So conical pile. It looks like this. So probably something dripping here. So you make a conical pile like that, and they gave you dv dt is 3, okay, cubic feet per minute. That's how fast the volume changes. What it said is let's say this one radius and this one is height h, and then radius is said that always equal to twice each height. So twice each height. Okay, that's a relation. Now, so your volume of the cone, 1/3, you need to memorize it, pi r squared times height. Okay, now what is the question? What is the dh dt? They ask you the rate, the height is changing at h equals 10. Okay, but before you take a derivative, since this all variable, then you need to make it only in terms of h. Okay, so you substitute this r into here. So v is 1/3 pi. Instead of r, 2h you substitute. So then pi over 3 times 4h cubed, right? H squared times h is h cubed. So that's v. Now when you take a derivative, dv dt, so 3 cancels out, so 4 pi h squared dh dt. Now you substitute what you know. So dv dt is 3, 4 pi, h is 10 square 100 times dh dt. So your height changing dh dt is 3 over 400 pi. Okay, you can leave it like that. You cannot reduce anymore. And then rate is the unit is feet per minute. Make sure you put the unit. Okay, that's how you're gonna do. Now let's move on to number 5. An open box with a rectangular base to be constructed from the rectangular piece of cardboard, 16 inches wide and 21 inches long. By cutting the square from each corner and then folding up the resulting size. Find the size of the corner square that will produce a box having the largest possible volume. So when you draw the diagram, so you have a rectangle right here. Now this one's 16 by 21. So let's say here 16. I'm gonna omit the unit. This one is 21. Okay, that cardboard, rectangular cardboard. By cutting the square, so let's say you're cutting the corner. So those are square, x like that. Cutting corner, and those are dotted line is a folding line basically, right? So after you cut the corner, and then you fold up, then in 3D you will get this kind of rectangular box open top, right? So height is x, and this one right here is 21 minus 2x, and right here is a 16 minus 2x. The reason why this is 16 and then you subtract x and x. Okay, so from here to here is a 16 minus 2x. Similarly, this is 21 and then you subtract x, then this one is a 21 minus 2x. So then this one is 21 minus 2x, and right here is a 16 minus 2x. Now you can find out volume. So volume is base area times height. So height is x, 21 minus 2x, and 16 minus 2x. Okay, that's the volume equation in terms of x. Now you can find out domain first. So domain for x, of course, x is greater than 0. But this one should be less than 8, right? 2x, let's say x you cut it a lot, but x cannot be over 8, right? Then this one 8 already cut it everything, so should be between 0 and 8. That's your domain. Now when you multiply it out, this one x, so let's say v of x times, when you multiply it out, 21, let's see, 21 times 16 is 336, and then minus then 74x, which is when you multiply and add up, okay, the 36 minus 74x and plus 4x squared when you multiply it out, when you fold it out. So your v of x is a 4x cubed minus 74x squared plus 336x. Okay, that's your equation. Now, to find out your maximum volume, largest volume, maximum volume, you have to take a derivative to find the correct value. So 12x squared minus 148x plus 336. Okay. So from here, you can reduce by first of all 4. Okay. So then if you reduce by 4, then 3x squared, and then set equal 0. That's why you can reduce by 4. Minus this one is 37x plus 84. Okay. You can reduce by 4. Okay. I'm not gonna put equal sign here. Now when you factor this one out, then you get 3x. You have to work it out to factor, and this one x minus 3 and equals 0. So I got x equals 3, or x is 28 over 3. But 28 over 3 is over 8, so that doesn't make sense. So only this, right? So you can prove it. You can justify your answer. You have a maximum volume. So v prime, you put it 3 here. And then using that equation right here, so you can substitute like 2 or 4. And then you will see you're going up, going down, okay, by picking that number. So you have a max that time. So question was find the size of the corner square. So your x is your size corner here. X is 3 unit is inches. Okay, 3 inches will be your final answer. Okay, so let's move on. Here, number 7. Water is withdrawn from the conical reservoir, vertex down. So conical reservoir, but it's upside down, your cone, like that. Okay, let me draw like this. Almost always you draw your height and radius. If the diameter is 8, that means you're 4 feet. Okay, that's your radius, and 10 feet deep. Okay, and then let's see your water is somewhere here, and then this is R and this one H. Okay, so you know this triangle, right triangle, and that right triangle, and they are similar. Similar means you can make a proportion. So R over H equals 4 over 10. Okay, then you can reduce by 2. So leave it like that for now. Now, so your volume, let's see what they gave you. So this is constant rate. It's kind of cut, but that's a 5, actually 5 cubic feet. So dV dt is 5 cubic feet per minute. Okay. Now, question is how fast the water level falling. Okay. So what is the dH dt when H is a 6? Okay. So but okay, the situation is was a water all here, and then water is dripping here, right? So it's withdrawn from the conical reservoir. So how fast is on decreasing? So your answer should be negative. Remember that your answer should be negative value. Okay, because it should decrease. Now, so your volume is 1/3 pi r squared times height. Okay, and then you're looking for dH dt. So r equals 2/5 h when you multiply h both sides. So I'm gonna substitute. V equals 1/3 pi. R is a 2/5 h squared times h. So then you can multiply it out. So 4 pi over 25 times 3. 75 and h cubed. Okay, so dV dt is 4 pi when you multiply. So that's 25 and h squared dH dt. Okay, you take a derivative this one in terms of t both sides. Okay, now so you can substitute what you know that. So that's a -5, right? So -5 because water they're losing volume. And 4 pi over 25, and h is 36. H is a 6 and square is 36, and dH dt. So your final answer dH dt, like I say, is a negative. So negative 125 over, what is it, 36 times 4? 36 times 4. So you get 144 pi. Okay, so unit is feet per minute. So you can say 36 times 4. Yeah, negative 125 over 144 pi cube feet per minute. That's what you're gonna get. Okay. All right. So now next one. Okay. Okay. Now number 8. A boat is pulled in a dock by a rope. One end attached to bow of the boat, and the other end passing through the ring attached to the dock at point 4 feet higher than the bow of the boat. So if the rope is pulled at the rate of 2 feet per second, then how fast the boat is approaching to dock when 10 feet of rope are out. So the situation is you have a boat here and there's a dock, right? There's a dock and you pull this on, okay? You pull, there's a ring and you pull this one, right? And then you can, they said is this one from here to here, that is 4 feet high, okay? It said that 4 feet higher, okay? And then rope pulls out. So let's say this on X and Y here. So dy dt is -2 because you pulls out -2. Now question is, what is the dx dt when y is 10 feet? Okay, that's the question. So you can have equation x square, Pythagorean theorem, so 4 square equals y square using that right triangle here. So that's Pythagorean theorem. Now when you take a derivative in terms of t, 2x dx dt, and the 16 is gone, right, when you take a derivative, and this one 2y dy dt. Now when y equals 10, you need to figure out x value. So here 4 and this is 10 and this is x, then x squared plus 16 equals 100. So x squared equals 84. Then x is a root 84, which is you can reduce by so 2 to 21, right? 2 to 21 feet. So you can substitute what you know so far. So 2 cancel out. 2 to 21 dx dt, that's what you're looking for. Dx dt equals y value 10, dy dt is a -2. Okay, so from here dx dt equals -10 over root 21 because 2 cancels out both sides. Then that's the answer, that feet per second. Okay, that's how fast the body is approaching to dock. Okay, you can leave it like that. Now next one, number 10. A Norman window is one in the shape of the rectangular topped by semicircular region. So that means you have Norman window looks like this, topped by a semicircle. Okay, let's label this on R here and this on Y. Okay, and what he said is a perimeter. I think you got 12 feet perimeter, and find the dimension of the window to maximize the area. So what you can do to find out maximize the area, so you can say first this one is 2r and this one y. So your 12 equals basically 2r plus 2y plus this one right here. 2 pi r is a circumference of circle, but only half of that. So pi r, right? Instead of 2 pi r, 1/2 times 2 pi r is a pi r. Now you can isolate y. 2y equals 12 minus pi r minus 2r. You can divide by 2, so 6 minus pi over 2r minus r. You can leave it like that. Now I'm gonna find the area, entire thing. So 2ry is right here, 2ry, and this one is a pi r squared but divided by 2. So oops, it's the red one, pi over 2 r squared. That's the area of semicircle. Now what you can do, so you can instead of this, so you can substitute instead of y. So then 2r times 6 minus pi over 2r minus r plus pi over 2r squared. So when you multiply 12r minus pi r squared minus 2r square plus pi over 2r square. Okay, so you can simplify further. Those are like term. So 12r minus 2r square minus pi over 2r square. Now let's take a derivative. So 12 minus 4r minus pi r, like that, right? When you take a derivative in terms of r. Right. Now, so set equal 0 to find the critical value. So 12 equals 4 plus pi and r. So r is 12 over 4 plus pi. So the dimension on the bottom, right here, that's a 2r. So 2r is basically 24 over 4 plus pi feet. That's the dimension on the bottom. Now, I'm going to find the y value. Y value you can use from here. So 6 minus pi over 2, r is 12 over 4 plus pi minus r itself. So 12 over 4 plus pi. And this one you can reduce to 6. Now, common denominator is a 4 plus pi. And only 6 here. So you multiply denominator. So 24 plus 6 pi and minus this one 6 pi minus 12. So 6 pi cancel. And 24 minus 12 is a 12 over 4 plus pi. So that's y value. Okay, 12 over 4 plus pi feet. So those are dimensions to have a maximum area. Okay, so put it here. If you need to justify, then a prime value, definitely you gotta use a calculator because this number is not good. 4 plus pi, and then when you pick some number here, and then you can plug it into here, right? So then you will get pretty sure that's a positive, negative, right? Going up, going down. So you're gonna have a max. That's the justification. Okay. Now number 12, the Poster regulation requires the sum of the length, width, and girth of the rectangular box is to be shipped cannot exceed 64. Now, if the box is to have a square base and find the dimensions of the box with the maximum volume can be shipped. So let's quickly draw. So the base is a square, let's say XX, and the length is like this. Okay. So let's say this one is Y. And girth means, you need to know what is girth. Girth means this. So length times width plus height. That's your girth. Okay. So you can say 2x plus y equals 64. Is that here? Cannot exceed 64. So you maximum 64 to have a maximum area. And your volume is x squared times y. Okay. So from here, you isolate y. 64 minus 2x. So v of x squared, so you substitute here. 64 minus 2x. Now, when you multiply it out, this one, negative 2x cubed plus 64x squared. Okay, that's a v of x. Now, to find the maximum volume, you have to take a derivative. So negative 6x squared plus 128x. Set equal 0. You need to find the critical value. So from there, you take out negative 2x. So then 3x minus then 64 equal 0. So x is 0. That doesn't make sense. X is 64 over 3. So that's the value you're looking for. Now, to justify your answer is a maximum. So then also v prime of x, you can do 64 over 3. And you pick some number here, and then you make sure you plug it into here. Then you will get positive, negative, so going up, going down, so max. Okay, that's your justification. Now, so what is the total final dimension? So we got x equals 64 over 3 inches. Now, what is the y value? Y you can substitute here. So 64 minus 2 times of 64 over 3. Then common denominators. So 64 times 3. So you get 192 over 3 minus 128 over 3. So 192 minus 128, 64 over 3 inches. Okay. So okay. So they are same. 64 over 3, 64 over 3. Those are dimensions to have a maximum volume. Okay. Now, last one. The rectangular plot of area 1,000 square feet is to be made into rectangular garden surrounded by 3-foot wide walkway. What should be the dimensions of a 1,000 square feet plot so that the garden has a maximum area? So let's see, you draw garden, rectangular garden. Only thing we know is their area is 1,000 square feet, right? So then what you have to do, let's say this one x, this dimension is y. So xy is 1,000. That's what they gave you. And you need to find out walkway. So each side is a 3. This is also 3. So you can say right here is x minus 6 because 3 minus 3. I mean x minus 3 minus 3. And here also similarly y minus 6 also. Right? Then your area of the garden is x minus 6 times y minus 6. From here, y is 1,000 over x, so you can substitute. So a of x equals x minus 6. Instead of y, you substitute 1,000 over x. Okay. Now you distribute. So your a of x, FOIL it out. So this time this, just 1,000. And this time this, minus 6x. Minus this time this, 6,000 over x. Last one, plus 36. So you can collect like terms. Negative 6x minus 6,000 over x plus 1,036. Now you take a derivative to find out critical value. Always the same rule. After you set up, you take a derivative. So negative 6. This one is a negative 6,000 over x means to the negative 1. So negative 1 times negative is a positive. And 6,000 over x squared, right? You subtract 1. So x and negative 2 means x squared on the denominator. And 1,036 is gone, right? Any constant. Set equal 0, and then I need to solve for x. So 6,000 over x squared equals 6. Now when you cross multiply 6,000, 6x squared, so x squared equals 1,000. Okay. So from here, what is x? X is a root 100 times 10, right? 1,000. So 10 root 10. Okay. So that's the dimension x value. But how are you gonna justify? So your a prime area, in a number line. So 10 root 10. Also, when you plug in before and after, to have a maximum area, so you should do it this way, right? So max. Now, to find out y value, y is 1,000 over x. 10 root 10. So this one is 100. So 100 over root 10. And then when you rationalize root 10 times, you multiply root 10. So denominator will be 10. So 10 root 10. So your dimension x and y is also same. Okay. The unit is feet. 10 root 10, 10 root 10 feet. Oops, 10 root 10 feet. So to have a maximum area, you need to have that dimension. Okay, for that area of garden. I mean this side of garden here. So I mean this one is 10 root 10, and this y value also 10 root 10. Okay, that's it for this video.